Okay, we're back. Sorry, the Wi-Fi problem, and we may have a solution here. Actually, now it's streaming way better than before. So yeah, I hope this solves our problem, and then I can stream normally from now. That would be amazing. And yeah, so yeah, now I in my preview I'm smooth. I'm not like very. So yeah, I may have solved the Wi-Fi problem. So which is a good news. But then yeah, we'll worry about the rest later. So I think we got cut off like here at 11.2, which is controlling how the tests are run. So you know, in PyTest, right? Again, Python reference. In PyTest, we can use different options to kind of maybe select certain files or do something about the test to kind of have more control. So with cargo test, we also have that option. So this is the dash dash separator. And if we do cargo run help, we will see some help about cargo and a cargo test. So we would have all these things. Yeah, so there's some help here. Or if we do cargo test dash 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 help, then we'll see how to use the dash dash operator like this. So it will actually teach you how to write the test as well. So there's like test, should panic, ignore. We have already seen them. So sorry about this being so small. Yeah, now you see better. Yeah, so moved on. Running tests in parallel and test thread equals to 1. I think this is the default. If you don't want to run the test in parallel, oh no, it's not. So I think the default is running it in parallel. Oh yeah, by default they run parallel. You should read. Meaning that they finish running faster. But I don't know how. I don't think I have too much thread in this computer, so don't think that make a huge difference. But if you run on a more modern machine, yeah, this computer is like, how long? It's like 3 years old now, probably. So yeah, I got it at the beginning of the pandemic, so it's quite old. Also, it's like not the top spec when I got it. So yeah. Each of your tests runs some code that creates a file on a disk. Yeah, some tests that you can't run it in parallel. Test output.txt and then write some data. Each test reads the data in that file and assert contain a particular value which is different in each test because the tests run at the same time. One test may overwrite the file at a time. So no, we can't have multiple access of the same file. It will have funky behaviors. The second test then will fail. It's not because the code is incorrect, but because the tests have interfered with each other in parallel. So yeah, some tests just can't be done parallel. One solution is to make sure each test write in a different file, or you can run each test at a time. If you don't want to run the test in parallel, if you more fine-grained control, then you can use test threads. Set to run that one, then it will just run it not parallel when using one thread. Showing function outputs. By default, if a test passed, then there will be no output. If we go print line in a test and the test passed, you won't see the print line. You won't print it out. You only see the line that indicates that it passes. Has set a function that prints the value of the parameter and returns 10 as well. And the test passes. One pass, one fail. Got the value 8 and then return 10. So one will pass, one will fail. So if we try that, if we run cargo tests, then we'll have one pass, one fail. We only get the panic failed message that the assert failed. So we can't see the output or the print. I got the value. So what you could do may not be the best solution, but yeah. So if you want to show the output, then oops. Oh, why this? I copy the $ dummy. Then what we'll see is that success. We'll also see the output of the success run as well. Failures, we also see the output, but then we also get the all the fail messages, the error messages. So running a subset of tests by name. Is this parameterized? Is this parameterized? Is it? So yeah, we are like running this very simple function again to test it, and then we try different values. We have 4, 5, and 102. You know, like yeah. They do the same thing. It's just that we change the value. So yeah. So we only want to run one of the tests. So okay. So yeah, this is super silly, but we are not parameterize it because we want to try out just selecting one test. So we have 3 passes, but what if I just want to test one of them? For example, yeah, the test run in parallel, so it's like that. But yeah, I want to only test 100. Then I just pass the name 100 there. So then it would just run one test. Yeah, so we have 2 filtered out because we didn't select them. So again, this is useful when you have changed certain feature in your code or just fix something. You know that there's only one test that's related to that, and you want to rerun that test only just to help you to fix the bug. And then maybe after it's always a good idea to run the whole test at the end, but while you're fixing something, you can just run one test to make it faster. So yeah, we see 2 filtered out. Or we can filter to run multiple tests. So only part of, so we can also like kind of grab so only like, oh, I only want to run this too. So I want to grab the test name with the add, then I can also give a partial matching of the name here with add. Ignore some tests unless specified requested. So for example, we use the ignore attribute, then after, yeah, we add ignore. For example, we add the ignore here, and then we would just have 2, right? Oops. Yeah, so we only have 2. But it's listed as ignored. If you will run only the ignore test, so maybe, I don't know why, but if you only want to run the ignore test, you can also use the -- ignore. Then instead it will just run the ignored one. So yeah, so you can have control of what you want to do. So if you want to run everything, you can also use include ignore, so everything will be run. So like here. Yeah. Okay, so moving on. We are doing well. Now the stream, I feel more energy like when the stream work, because like otherwise it's very, very sad, and I just like look at myself, and then I was like, oh my god, the stream may not work, and thank god. Okay. Test organization. Oh, we're talking about unit tests here. Okay. As mentioned as the part of the chapter, test is a complex discipline. Different people use different terminology, organization, different like ideology of testing. The Rust community think of tests in terms of two main categories: unit tests and integration tests. That's the more common way of thinking it, I would say. Is this how I think about tests as well myself? Unit tests are small and more focused, testing one module in isolation at a time, and can test private interfaces. So, like for example, you have lots of helper function. You can like test each one of them. It's very easy to see what works, what doesn't work, what is broken, what is not. Unit tests are small, yeah. And then integration tests are different. Testing the entire external to your library and use your code in the same way any other external code would use. So this is basically kind of like user tests, right? Like how people use it and to see if it come out expected and it's kind of working. It's only the public interface and potentially exercising multiple modules per test. Writing both kind of tests is important to make sure that the piece of your library is working. You expect them to separately and together. So yeah, test everything work and then test the whole thing work. So independently everything seems fine, and then collectively they are also fine. So this is like the way of trying to cover every single corner. So unit test. The purpose of unit test is to test each unit of your code in isolation. So you can put unit tests in the source library. So the convention is to create a module named test in each file to contain the test functions to annotate the module with CFG tests. So tests, so in Python all the tests are put separately, right? But in Rust you put them together with the code, which may be a good thing because like it's like docstring, you can keep everything together. And put the tests together, the test function, and also you don't have to switch between a lot of files. Annotate the module with CFG tests. This is module and CFG tests. The CFG test annotation, so I guess it's configuration, on the test module tells Rust to compile and run the test code only when you run cargo tests. So because we have put this in the module, so this is only for cargo tests, not when you run cargo build. So everything within this module is ignored when we build our module. Save compile time. When you only want to build the library and save space in the resulting compiled artifact. Yeah, the reason why also Python we put it separately is because when we build a wheel and stuff, then we can ignore the test files. Because tests are not included, you will see that because integration tests go in different directory. Yeah. Also, integration tests will put them separately because again, those like you don't know where to put it, right? Like because unit test is natural that you can put it together with where the code that you're testing is, but integration test, it tests everything, so you need to go outside, go to a different directory. They don't need a, so if we write integration tests because they're put separately, then we don't have to mark it with this annotation. However, because unit tests go in the same file as the code, then you use that to specify they are not included when you building your application. Recall that when we generate the new Ada project in the first section of this chapter, Cargo generates this code for us. This code is automatically generated test module. Configuration, tell Rust that CFG usually means configuration, and tell Rust that the following items should only be included given a certain configuration option. In this case, the configuration option is tests, which is provided by Rust for compiling and running tests. By using CFG attribute, Cargo compile our test code only if we are running tests with Cargo tests. And this includes any helper function that may be written within this module, in addition to the function annotated with hash tests. So, testing private functions. Okay, this is debatable. Whether or not private functions should be tested directly and other language make it difficult or impossible to test private functions. Regardless of which testing ideology you adhere to, test privacy rules do allow you to test private functions. For example, we add a internal header, so it's not pub, and the test module is just another module. So as we discussed in the path for referring to an item in the module tree section, item in the child module can use the item in the ancestor module. So in this test, so in this test, we bring all the test modules parent item into the scope with superstar. And then we can call internal header. If you don't think private functions should be tested, there's nothing in Rust that will compel you to do so. So you don't have to do it if you don't like it, but you can still bring this internal header into here. So yeah, so because like we bring it into the module here, the test module, then it's fine. Bring all the test modules parents item in the scope. Yeah, so because the internal header is in the scope, so all the child can use it. So for example, I can use internal header here. There's no problem because everything is in the test module. It's kind of put everything in this file in the test module basically. If you don't want to test this, it's fine. If you, I guess without it, then this one will fail. Let's try. So if we do this, we can test okay, but if we remove this, so this is not in the scope, so if I do it now, will I get a compiling error? Yes, it's not found in the scope. So if I use add to, is this okay? Also not found, so you have to do that. Because it's not in the scope. Or if I do super add to, maybe this will work. Unexpected argument of remove. Oh, so I only need 1, 2 here. Yeah. So for example, like that. Yeah, you can still test your public function, but I guess you can't use internal header here because this is internal. So it's still fine. I guess because it is. So yeah. Oh, because this is the parent. Okay. So yeah, this. So because this is at the same place, so so the parent is this one. So all the child can see it, so we can see it, but you don't have to if you don't want to write it, because if you don't want to test internal function, it's absolutely fine, just test as to, but you can also do that, but it's just that if with the line that bring it into the scope, you don't have to write super, but it's accessible because this is a child within this module, and so it can see it, but there's no harm of seeing it even if you don't use it. Integration test. So add external to your library, so you add the test like this. They use your library in the same way as other code do it, so that's why you put them separately. So yeah, it tests the public APIs. Unit of code. Yeah, sometimes they will have problem when they're integrated, so you have to test them together. So we create a test directory. something like this. So I'll have to click this one. This is how it works. So test. Right. Yeah. So now I have tests, and then I can have integration test.rs. New file. Right. Now there's nothing, but we can call in our module like that, use editor, and then do whatever it is doing. We don't have that right now. What we have is add to. So we can do that. Oh, S2, yeah, it's just S2. So this one we will be fine. Just test the Plotback APIs. Each file in test directory is a separate crate, so we need to bring a library into each test crate scope. So this reason we'll use editor, then we can use the editor thing here at the top of the code. We don't need that in unit tests because it's together, and we don't need to annotate any code with the configuration tests. Cargo treat test directory separately and compile files in the directory only when you run cargo test. So it's already detected automatically that this is a test. And the 3 sections of output include the unit test, the integration test, and the doc test. So it's more or less the same thing. Let me fix up this first because I've changed it. So I don't know, I could introduce some mistake here. So let me yeah, let me fix this up. So we have integration test. So let's try running tests. Okay, why ignore? Not that I have any ignore, but so I have one test that passed. Internal one, and I test it as 2. That's 1. So they are put separately. Here result running one test. Oh, because they're different files, I guess. Yeah, so this one is here, this one is here. Okay. Any test in the session fail, the following session will not be run. If a unit test fails, there won't be any output for integration and doc tests. So for example, if we failed it here, if we put it in 5, then we failed it. Then we only try this. We haven't tried integration test because if one fail, then no point running the whole thing. Yeah. Then next session, yeah, is the integration test. Then there's the doc test. Each integration test file have its own section. If we add more files in the test directory, there will be more integration test sections. We can also specify which integration test to run. Use the test argument of test file name of the file. For example, like that, test, and then test integration test. A lot of tests here. Yeah, but you can specify a file like this. So module in integration tests. Add more integration tests. You may want to make more files. For example, you can group the test functions by the functionality that they are testing. Each file in the test directory is compiled as its own crate, which is useful for creating separate scope to a more closely intimate way. And you'll be using a crate, so you can create different use cases, I guess. However, this means file in test directory won't share the same behavior as file in source do. Yeah. The different behavior of test directory file is most noticeable when you have a set of helper functions that use in multiple simple integration test file, and you try to follow the steps in separating modules into different file section, extract them into a common module. For example, if we created common.rs and place a function named setup there, add some code to set up that we want to call some multiple. So let's say we have setup, so setup would be another thing. Here, yeah, zero test, but it's there as common.rs. Appear in the test. This is not what we want. So this setup supposed to set up code specifies your library's tests. So it's kind of like a config test in PyTest in Python. So you have common thing, which is something that you share between all the tests. So you put it like that as a directory, and then mod. So it look like that. It's just order naming convention. Yeah, so remember that when we have a module, we can also like open a folder and then have mod. This is the older convention. Tell Rust not to treat the common module as an integration test file. So it will no longer appear if we do that. I don't think we need to try that. We just take it or take what they said of this. Files in subdirectory of test directory won't get compiled as separate crate or have sessions in the test output. After we have created that, we can use it to from any of the integration test file as a module. So for example, we add something in the setup, so we can also put it in here in scope. Then then we can use it if we want to. This decoration is the same as the module decoration. Yeah. 721. Do we have a 21 here? Listing 721. Okay. Yeah, so the module is in this scope, but then like the definition is somewhere there. Yeah, so it's like it's a submodule of the tests. Integration test for binary crates. If a project is a binary crate that only contains a main.rs file, doesn't have a lib.rs file, we can't create integration tests in the test directory and bring functions defined in the main rs file into scope with a use statement. Only library create, yeah, because main you're supposed to run it, right? It's not a module, so you can't bring it like here, use adder kind of thing. Only library create exposed function that other cranes can use. Binary crates are meant to be run on their own, so you can't. This is one of the reasons Rust projects that provide a binary must have a straightforward main rs file that calls logic that lives in the libs file. So usually the main rs is the front. You would have everything built in the librs, and then you can test all of them with the use in the test. But the main one should be very straightforward and simple, and just using everything you have written in lib. like important functionality available. If the important functionality works, then the small amount of code in the main RS file will work as well. So don't put too many things in your main RS. Those are just for running your code. So it doesn't need to be heavily tested. So summary, Rust testing feature provide a way to specify how code should function to ensure it continues to work as you expected, even as you make changes. Unit tests exercise exercise different part of a library separately, and it can test the private implementation. Integration tests many parts of the library together, and also only test the public API. As if the external code is using it, even though Rust type system and ownership rule help prevent some kind of bugs, tests are very important. So write tests, people. Write more tests. So I guess that's it. I think maybe next time we can do some rustling. So GitHub. Oh, solution. Is it this one? Yeah. Okay. So yeah, next time maybe we can try this, because there are a lot of things. I know there are different chapters there. I don't know whether, like, if we, for example, follow the instructions and run it. Yeah, Xcode, I have those. It's fine. I'm already running Rust. Or we can run it on browser. Yeah, I don't know whether it will, because I run my exercise one. Verified. Doing exercise. The exercise is sorted by topics and can be found. So so there's no specific order. We can find a topic, for example, like the one that we have already learned. Our topic that external additional README file with some resources to get you started on the topic. Have a look at them before you start. Task is very simple. Contain an error that keeps them from compiling. Fix it, and some. Also run a test. So let's have a look at one that we already know. Exercise. For example, enum. So there are 3 exercises and pattern syntax. Oh, will it be too difficult with this? Because we have kind of learned enums, no? Yeah, we learned it from the book. But we haven't learned this. This is chapter 18. I'm a bit scared. Do I have to learn everything before I start? If, for example, if control for this one doesn't have to. Or is it more handy? We just like read the book first and then do this, and then I'm sure like when we do this, then we would kind of refer back to the book sometimes. Let me have a thought about it. I am not sure yet. Maybe I can select a few of these that, for example, it doesn't kind of have relations. Some of this one we have read it, like, yeah. So maybe we can do a few of these, and just to recap, because I start forgetting what I learned already. So let's like lock in this knowledge, make it solid. Then before we move on and dive into more difficult topics. So yeah, we can do a few of these, and it's more fun to watch than me reading the book, which is a bit dull. So yeah, maybe we will do that. The internet problem is fixed, hopefully, touch wood. And then yeah, it will be much more fun for me to stream, and more fun for you to watch as well. So that's it for me for now. It's kind of afternoon for me. I have other things to do, like, you know, I don't have a full-time job, but I still have things that I have to do as a human being. So yeah, so I may come back tomorrow, or if I don't have time, maybe Saturday definitely, but we'll see. Today and tomorrow is quite busy, so we'll see, and I promise I'll come back and do some wrestling. So cool, see you next time.